So students, welcome back to the channel where we try to make math a bit more fun, and today we are going to be continuing our inverse trigonometric function series, active series. So let's get right into it. I just don't want to talk much today. Okay, so our first, we're going to be talking about a few identities here today. First one we're going to be talking about is there is two sine inverse of x. It can be written as sine inverse of x plus sine inverse of x. You know for the formula for that formula for sine inverse of x plus sine inverse of y. This times x and y is same. This would become x times root over 1 minus x square plus x times root over 1 minus x square. This would become just sine inverse of 2x times root over 1 minus x square. Okay, 2 sine inverse of x is sine inverse of root over sine inverse of 2x times root over 1 minus x square. For cos, cos inverse of x, it can be rewritten as cos inverse of x plus cos inverse of x now again we can apply that formula for cos inverse of x plus cos inverse of y where x and y are the same. This would become cos inverse of x square minus actually let me do it this way, cos inverse of x times x minus root over 1 minus x square times root over 1 minus x square. So just become cos inverse of x square minus 1 plus x square. So this just becomes 2x square minus 1. Okay, now for tan. Two times tan inverse of x. This can be rewritten as tan inverse of x plus tan inverse of y plus tan inverse of x again, and we can again apply the formula for tan inverse of x plus tan inverse of y. In this case, x and y are the same, so this will become tan inverse of x plus x over 1 minus x times x. And so just become tan inverse of 2x over 1 minus x square. Now this gets a bit more interesting because I can manipulate. Well, what I'm doing here is we're going to be manipulating this thing a bit here. We could have done it with the previous operators as well, but this one is a bit more useful. So I think in one of the previous videos I have told you guys like how I can represent a single any particular angle in the format of any inverse trigonometric operator, be it sine inverse, tan inverse, cos inverse, sec inverse, cot inverse, anything. I'm not doing that here. This can be rewritten as sine inverse of. First of all, tan inverse is tan just gives us the ratio of length over base. So you know the length is gonna be 2x. And what's gonna be the base? Base is gonna be length squared plus base squared. and this would just become 4x square plus 1 minus 2x square plus x to the fourth, and this would just become 1 plus 2x square plus x to the fourth, which can be rewritten as 1 plus x squared. Now this square and this root would cancel out each other. This would just become, sorry, whatever square here is, 1 plus x whole square of that. No, 1 plus x square whole square of that. And at the end we are just left with this quantity, that is 1 plus x square. Okay, this is going to be tan inverse. For cos, we already know, first of all, cos is the ratio of base over hypotenuse. We know what the hypotenuse is. It's 1 over x square, and the base we know from here it's 1 minus x square. So cos inverse, this same angle would become cos inverse of 1 minus x square over 1 plus x square, base over hypotenuse. Now I think I have explained this in the previous video, like why are this cycle the same. I think I don't need to explain it again. Anyway, let's see what ideas do we have. Let's get done a few more. Let's get a few more done. Let's do this one. First of all, sine inverse. Say this proof itself is this formula itself is that sine inverse 3 times sine inverse of x is going to be sine inverse of 3x plus 3x minus 4x. 3x minus 4x cube. Now, how did we get here? First of all, let's say that sine inverse of x is theta, so sine theta would be x. Now there is a trigonometric identity that says that sine 3 theta is going to be the same as 3 sine theta minus 4 sine cube of theta. Now if you are wondering where did this one come from, actually it's not very difficult. You can basically write this as sine of theta plus 2 theta, and then it can be proved like sine of equals b. You will come across cos of sine of 2 theta, sine of theta plus theta, and cos of theta plus theta. So those can be further expanded like that, like what is it called again? Like a compound angle, and using basically what we will be doing after that is we will just be algebraically manipulating them and expanding them, those expressions. Then you get to this formula sine 3 theta equals 3 sine theta minus 4 sine theta. You guys can very easily do that proof on yourself. But if you guys still face a few difficulties with that, then you can let me know about that in the comment section. I can help you figure that out. Okay. And back to this. From here you can get is 3 theta is gonna be sine inverse of 3 sine theta minus 4 sine cube theta. Now look at here. The theta is sine inverse of x, so 3 theta can be written as 3 times sine inverse of x, and in this side we have 3 sine theta minus 4 sine cube theta. You know that sine theta is x, so we can write this as 3x minus 4x cube. Okay, we have a formula here that is 3 sine inverse of x is the same as sine inverse of 3x minus 4x cube. Okay. Now you can do the same for cos as well. But actually, you know what? Let me do it. It's not that hard. So because I mean that is why I don't want to get into this. You know what? You can do the cos 3 theta proof yourself. This one says that this one says that 3 times cos inverse of x is gonna be the same as cos inverse of 4x cube minus 3x. Okay, you can do this proof for yourself. It's not that difficult. What I'm gonna be doing right now is let me prove to you that sine 3 theta is gonna be 3 sine theta minus 4 sine cube theta. Okay. So first of all, let's rewrite this as sine of theta plus 2 theta. This can be expanded like this: sine theta cos 2 theta plus cos theta sine 2 theta. Okay. Now again, you can rewrite the cos 2 theta here as cos of theta plus theta plus here we have cos theta times again sine theta 2 theta, and here we have sine of theta plus theta. Now this can be rewritten as sine theta times cos theta minus sine theta times sine theta. As far as I remember, I have proof of these trigonometric identities as well. Like how does sine a plus b become sine a cos b plus cos of b. So you can check that out as well. Plus we're going to be adding here is cos theta times sine theta cos theta plus cos theta sine theta. This can be rewritten as sine theta times cos square theta minus sine square theta, and this can be rewritten as cos theta times 2 sine theta cos theta. Now the entire expression I can rewrite cos theta as root over 1 plus root over 1 minus sine square theta. So this will become sine theta times root over 1 minus sine square theta whole square of that. So the root and square will cancel each other. We're just left with this 1 minus sine square theta minus sine square theta plus root over 1 minus sin square theta times 2 sin theta times root over 1 minus sin square theta. And eventually write something here. This will become sin theta times 1 minus 2 sin square theta, and we are going to be adding what we are going to be adding here is 2 sin theta times 1 minus sin square theta. So now we are going to multiply this. So this will become sin theta minus 2 sin cube theta plus 2 sin theta minus 2 sin cube theta. And this can be written as 3 sin theta minus 4 sin cube theta. Okay, so you see it's not simply that complicated. Sin theta becomes this 3 sin theta minus 4 sin cube theta. Now we can definitely do this for cos as well, and you can find out what you know 3 times cos inverse of x is. It's very easy. I can just I'm just gonna write it down here. 3 times cos inverse of x is the same as cos inverse of 4x cubed is 3x. So I would just recommend you guys trying to prove this formula at your home, because I mean if I just spoon feed you all the formulas, math is just gonna feel like a boring subject where you just have to memorize all the formulas and you just won't feel like you're putting an input on yourself. And I think this is where our education system gets it really wrong. We should try to make students feel that they're also putting an input of their own. So according to with the help of everything I've taught you guys so far, I think you should not have any problem in proving this identity. If you do, then you can let me know about that in the comment section. I can definitely I'm definitely gonna make a video proving this one. Okay. So this is where I'm gonna wrap this video up. If you guys think that you have any doubts regarding anything I've taught you guys today, you can definitely let me know in the comment section. I will try to resolve your doubts, and until the next one drops, keep learning.